So in week 1. Goodness, where's my mind already? It's already flying by. Week 1, day 2, part 2. We're talking about loops and conditionals, and that will lead us to working on our homework. So that's why I like to tell you what your homework is going to be, so that you can frame how you're thinking about your project for the evening in what we are learning. So that you're like, hey, what am I learning today that will help me be able to do my project? So that's why I do it. It's on purpose. It's not just me like, oh, that's how I do it. There's a really good point to it. So in the terminal, let's set ourselves up in the terminal because we're gonna have to run some Python code. So let's go back a couple of directories, back to our notes directory. So to do that, we're going to do cd, and we say cd ... to go back one level, right? But you can also do cd ... /.. We'll go back 2 levels. And now we're at the Carolina Code School directory. We want to go all the way back to Carolina Code School so that we can go into our notes directory. Because we're doing this just because I know I'm going to write some Python and I want to run some Python. So let's cd into our notes directory, and let's cd into our week 1 directory. So when you do a pwd, you should see that you are in Carolina Code School Notes Week 1. If you are not in Notes Week 1, let me know and we can get you there.
So I kind of got an interesting error. It said Darren arrow as blocked. So just run to allow it again.
What directory were you in?
I was in assignments, and then I went back to notes.
So when you went into notes, it said the Durham is blocked? Okay, that's fine. You can say Durham allow there. Because I think we did that with our notes. Notes is a Durham project. I don't know why I wouldn't have given it to you yesterday, but we'll see. Yeah, just go ahead and allow it. It'll create the virtual environment, and you can work on from there. And then, yeah, cd on into the week 1 directory. Do a directory listing. We should see day 1 and day 2 palindrome. Sweet. Okay, so I'm going to jump over to Atom. You should have like 2 instances or maybe even more instances of Atom open. On my screen, they're small enough that they cover each other up, but this is my number guesser project, and I'm going to close out of that. So I'm going to do a close window, which is Command-Shift-W if you don't want to use File Close Window. So you can Command-Shift-W. That'll close out of that, leave me with just my notes open. Try not to have too many instances of Atom open. It will destroy your RAM. And by destroy, I mean it'll eat it. It's like the free real estate meme that's going around on the internet from Tim and Eric. It's just like Atom will take any free memory and eat it up. So try to just leave one version of Atom up and use that as like your persistent running. It's fine if you have like 1 for your notes and 1 for your homework. That's fine too. I mean, however you work really. So I'm going to create a new file here in week 1, and that's going to be a week 2 or a day 2, and this is going to be loops. So day 2 loops py in week 1. And so we're really covering 2 kinds of loops here. We're going to cover the for loop, and we're going to cover the while loop. And this is one of those things that you as a new developer are probably thinking, why one or the other? Why would I have one? Like, why not just one type of loop, right? That makes sense. And we probably, I mean, you could, if you wanted to work hard enough, you could wedge the functionality of a for loop into a while loop, and you probably do the same with the for loop. Well, probably not. But they're for 2 distinctly different purposes. And I've got a great, what is it called? A great analogy to go along with them. We're gonna have to visualize some stuff though. So in a nutshell, here's the lecture part. I'm not gonna code at this point. So this is probably good note stuff. 1056, Joel goes into detail about loops. In a nutshell, a for loop is used when you have a finite amount of items that you want to loop through. And I'll talk more about what that means to loop through things, but we're just going to go to high-level details. And what I mean by finite is that it's like a fixed amount. You know how many times you want to loop through it. The for loop equivalent from the analogy would be like, remember, like think back like in high school, you're in high school gym class, and your gym teacher says you got to run laps around the building. The for loop version of running laps around the building are, okay, Kevin, go run 5 loops around the building, or 5 laps around the building. And every time you run around the building, 4 laps, 3 laps, 2 laps, 1 lap, and you're done. The entire time, you know how long you're going to be running. That's because you had the length of the duration that you were going to loop, and that was going to be finite loops around the building, laps around the building. That is how a for loop, that's the mindset you need to think of with the for loop, is that if you have a set number of things that you want to go through, like words in a sentence, or laps around a building, or just 5 times, you just want it to run 5 times, okay, that's fine. It doesn't have to be like tied to any form of data. It typically is tied to data, but sometimes you can just be like, I want to run this 8 times and then you're done. That's fine. For loops are great for that. The analogy, and so the difference between a for loop and a while loop is that a while loop is I'm sorry, I'm getting off track here. A while loop is for when you have an indeterminate amount of times that you want to run through the loop, meaning that you don't have the final number set in your head that you want to run through. So that could be like you want to run for time, you want to run for distance. So the analogy equivalent would be, instead of running 5 laps around the building, I'm going to say you are going to run laps around the building until I lower my arm. When you see my arm lowered, you're on your last lap. So you don't know how long you're going to be running. But there is a condition that exists that says you aren't going to have to run anymore. When my arm gets tired, I'm going to lower it, and then you're going to finish up your lap and you're going to be done. Now, if I was to tell you, so if I took all 3 of you outside and I said, all right, you can make a decision whether or not you want to run 4 laps around the next innovation center, or I'm going to sit there with my arm up, and you can decide which one you want to run through. And you're going to think like, okay, well, which one is probably going to run longer? Well, just by thinking of that, this is kind of a trick question. I always have this rule that I'm not going to trick you unless I tell you I'm trying to trick you. So this question is getting kind of tricky. Which one do you think that you would have to run more? If I said you have to run 5 laps around the building or until I lower my arm? Until I lower my arm?
Which one would be longer?
Yeah, which one would make you have to run more?
I don't think you want to hold your arm.
5 laps.
Yeah.
5 laps because you can choose if you've already accomplished the task that you want at any point. So like sit there.
I just don't think you want to hold your arm.
Also true.
So the idea, so we're kind of we're coming to the conclusion that, the condition of me holding my arm up is not, you have no control over that. Or like that is a condition that exists outside of the scope of you running around. The 5 laps around the building, that is something that there's a beginning to, there's an end to. You might be in shape, you might be able to knock that out no problem, and you might be able to sprint it and just be done because you don't know how long I'm going to hold my hand up. The real answer, like this is the reason why I said it was going to be kind of tricky. The real answer is that there's really no way to know. Like I could hold my hand up like for hours and you'd just be totally screwed. But that's because the while loop version of it, like that could just run forever, like hypothetically speaking. Like I could just prop my arm up like this, and that's technically we're going. And you would have no control over that. But that is the mindset to get into when you want to get into a while loop versus a for loop. Now, that's not to say, though, that one is longer running. Because I could raise my hand, shoot the gun in the air, and then lower my hand until I finish your lap. And then you're like, yeah, I only got 1 lap. And then everybody else is like, oh, I chose 5. So that's not to say that a while loop is going to run forever all the time. It's just that it's based on a condition that is not preset. Now, in this case, it's going to be like Joel lowers his hand. Okay, we're done. Whereas the for loop is we know that will be 5 times. It will be 3 times. Those are the differences between the loops. And so the reason I say that is because like a while loop could be used like I want to run as many times through this loop, before it gets to be like 1030. So it's like just loop as many times as you can. Use the processor, loop a trillion times, but until that time shows me that it's 1030, I'm going to just keep going. So that would be an example of a while loop. A for loop would be, I want to send an email to everybody's email address in this list, so all 3 of you. So I would take a list of strings of email addresses, and I would say do a for loop, go through each one, send each one an email. Call the email function. I don't know what function that is, but just call a function called email. It sends an email. We showed earlier that you can say I can have a blacklisted character in a list, like the bang, the space, the comma, the colon, and for each one of those, I want to call replace for each one of those. So that is why we would want to use a for loop, because we have a determined amount of things. So let's take a look at what that looks like. So let's say I want to I just want to print a statement 5 times. So let's say I want to, the way that you would do it without a loop is you would say my statement. You can type along with me. I'm just going to eventually erase all this, but you would paste that 5 times. And we would run it. We'd say Python day2 loops, and my statement would show up 5 times. But that's kind of annoying, right? Like we know that the amount of times we have to do it, but we have this code copied and pasted 5 times. So if your boss comes to you and says, we need to change that statement, says we need to change it to say my awesome statement. So then you as a developer have to be like, my awesome statement. My awesome statement. And remember what I said about yesterday about what kind of developer I want us all to be? Lazy, right? I want us all to be good, smart, curious, lazy developers. That's my ideal hire right there as a junior developer. Is you're a good, smart, lazy, curious developer. It's a good. Don't put that on your resume though. Like, convey that, but don't say it, because so. I want to set myself up as a developer to say, I want to be able to maintain this code because I have to maintain this code, or someone else maintains this code, and they know where I live, and a list of all of my fears, and they have a gun. So, I want to make sure that their life is good too. So instead of manually saying my statement 5 times, I'm going to say it once, but I'm going to have it loop through that. I'm going to have it loop through and say that statement 5 times. So in Python, the syntax for the for loop is to say for, and we're going to just do an underscore here, because an underscore is like a throwaway variable. We'll say for underscore in, and now we want to call it 5 times. So I can't just say 5 go, but I can say for underscore in range of 5, and then I would indent the print under that and delete the other ones. So this is kind of weird. There's a lot of stuff going on here. We'll see the for loop many more times, but you can't just say, I want to call this 5 times. The Python way of saying it is to say, I want a range of 5. Now, technically, under the hood, range returns a generator. I'm getting ahead of myself. It's basically a list with the number 0 through 4. But it's fast, so you don't have to really worry about what it's doing under the hood. Just know that this loop will be called 5 times. So that when I run this code now, notice it's still calling my statement 5 times. And so my boss can say, I want to change it to my awesome statement, and you'll be like, no problem, fam, my awesome statement now. And you can run it, and now it says my awesome statement. And your boss can say, I want it to run 100 times. No problem. I don't have to copy and paste those 5 lines 20 times. I can just change that 5 to 100 and watch it go. So, and notice how fast that was. Loops happen really fast, because they happen with, they're timed with your CPU. So if you have a really fast CPU, they're just going to go super fast, like a thousandth of a second between iterations. But the thing is that we just made our program run 100 laps around the building. So let's just lower that so it's a little bit more manageable, back to 5. Awesome. That's a for loop. Another way that you can use a for loop is to iterate. Iterate is just a fancy word for stepping over items in a collection. So you could say, I want to for loop over for a character in Joel. Now remember that a string is just a collection of characters, and I want to print out the character. What do you think that that's going to print out? Letters of my name, and they're all going to be on individual lines because the print function will do that. Each print function call is a new line. So that's going to say each letter of my name. You can put your name in there, doesn't matter. That loop will run as many times as there are an item in your name. You could also, instead of doing just a character and a string, you could say for item, and you can give it a list. I know we haven't talked in depth about lists yet, but you can say like dog, cat, and horse. And you can print the item.
So, like, character or item, those are basically like temporary variables?
Exactly. Thanks for pointing that out. I almost let that one slide. So you can see how we say for character in Joel and for item in dog. You ever watch like Disney sing-alongs? How there's like a little bouncing ball that goes over the word. Yeah, I this is a visual that a lot of people tend. Like, I guess I've been teaching too many kids classes, but like I talk about Frozen sing-alongs. They all know what I'm talking about. What's going to happen with this for loop is that the first time it runs, that little bouncing ball is going to grab the value of dog, and it's going to assign it to this temporary variable called item. And I could call this whatever I want it to. I could call this like unicorn farm or something like that. And now that does the same exact thing. Item makes more sense because it's generic. So I could call that temporary variable whatever I want to. And inside of this block, item is going to be equal to dog the first time it runs through. And then that bouncing ball is going to move through. So literally what's going to happen is it's going to go from here to here, and then it's go back up to the top.
What if you had an external variable called item and then have a for loop using item? Would it use the variable you created, or would it stay a temporary variable just before?
That's a great question. So the question was, what if I had another variable here called item that was like Joel's face, right? Like some random thing. What would be printed here? That's a great question. Before I run it, let's form some hypothesis. Because I know what's going to happen, but okay, I'll just get it out of the way. Is it going to error? I don't know, maybe. It's not going to error. It's going to be fine. But what do you all think is going to be shown when I print item here in the for loop?
So the colon makes me believe that it's to that set that you defined on top of it.
You mean this right here? What colon?
Yeah. Right.
This one? Okay. So this line right here, for item, when I print item. Okay.
Because the print's just going to run inside the loop, right?
Right. This is the print is going to be ran while the loop is looping, while it's iterating.
Right. So I would think so. It's just going to look at the items inside the loop.
Okay.
Well, I was going to say, if it sees the other variable, I would think it would reset it to dog. So I guess I would think it would print dog, cat, and horse. But then I guess the question is, after the for loop, would item remain as horse, or would it go back? Would it be Joel's face? So does the for loop actually change that external variable?
Great question. Great question.
That would print dog, cat, horse, Joel's face.
Dog, cat, horse, Joel's face. Okay, we've got one vote for dog, cat, horse, Joel's face. You think it's going to be dog, cat, horse, Joel's face? All three of you are wrong. I'll just say it, but
That's fine.
But that it's good that you're wrong, because we're forming hypothesis. We're like challenging. We're like trying to run this Python in our head. Like that's some next level advanced programmer stuff. Is that when you're able to look at code and try to figure out what's going on, your head is a much faster interpreter. Well, it's a smarter interpreter. It's not faster, I think sometimes, until you train it. But yeah, so what's going to happen? I'll walk us through this, and then maybe we can take it to an online step debugger. What's going to happen is that there is a variable called item here, the value of Joel's face. Then what happens is the for loop comes along, and it sets item to dog. It prints item. It gets to the end of the loop, and it goes back to the top. It sets item to cat. It gets to the bottom or gets to the loop. It prints item, which is cat. Gets to the bottom, goes back to the top. Then it sets item to horse. Then it goes to print item, which is horse. It gets to the end of the loop, goes back to the top, sees that there's no more items. So then it escapes out of the loop, and continues with the execution of the program. What was the last thing that I said item was?
Horse.
Item is still horse. And that's a major gotcha with Python programming because of the scope of how a loop can change something. So you can see we print horse twice.
That makes sense. It goes by the latest
Mhm.
definition of the topic.
Yeah.
So
Now
you
what-
have to be careful with your variable.
So exactly. Well, and that's so right now we're dealing with two what's called scopes, and scope is going to is basically a fancy way of saying what is the value of a variable here. What is the value of the variable not just here but now? So scope is going to sometimes cause you to lose sleep of variables, and I think Python does a pretty good job of variable scope. I think JavaScript is a little bit scarier with variable scope, so you have that to look forward to. And I say that with love in my heart, but Python I feel like deals with a little bit more sane way. There are three scopes that we need to always be aware of. There is like function scope, which we haven't talked about yet. There is global scope, and then there's this loop scope. Like there's like loop scope. Like the for loops have their own scope. So we overwrote item here, but because we're running it procedurally, it is going to have this value of item because it was the last thing of that variable name. But if we were like inside of a function and we created a variable called item in that function, and there's also a variable outside of that function called item, like, well, how do you refer to it? Like, if you want that variable that's global, like outside of the function of item, you don't want the one in the local function called item. One, you're doing a bad job naming your variables, but two, you'd have to specify that you want the global one. Like you have to opt in and say that's the one that I want over there. And we're not going to do that. I feel like when you do that kind of coding, it's one, bad practice. Two, it's a smell, and a smell in coding is you don't see the problem, but you sense it in some way. Like if you've ever entered a room and you're just like, I can't see what's wrong, but something's wrong. Something went to the bathroom on this carpet, and it's been cleaned, but not very well. That's kind of what a code smell is that you can see that something's wrong. Like you can't see that something's wrong, but you know that something is wrong with this code. And so when you're working with global variables, with local variables of the same name, typically that's a smell that you're not doing a good job naming your variables. But that's a great discussion question on variable scope. And this is something that actually trips a lot of developers up. Even like experienced developers, because top-down stuff, they might have, this is really nice and all when your programs are 16 lines long, but when they're 33 and 80 and 500 lines long, and you have a variable called item up at line 2, and then you do a for loop or something, and you're like, item's a nice generic name, right? So you say item, and then down at line 500 you refer to item, and now suddenly it's like the value of an empty string, or something random, like a null, or not a null, but a none, and it's not what it initially was set to at the beginning of the program, that's a problem that can be fixed with better variable names, or just using scope to your advantage.
And something like that, 500-line code, and you're going to have 100 variables. Would it make sense to keep a list of the variables that you create and what you're using them for? So if you're thinking of the name, we'll make sure I don't already have the variable.
Well, see, that's where function scope allows you to be saved. So when you have two functions, and I'm going to do this just for I'm going to do this for illustration purposes, not educational purposes. So if I have a function, func1, and I make a variable called myvar is equal to x, and then I make a def func2, I say myvar is equal to y, and I print myvar here. I print myvar here. I don't have a global my variable, but each function is going to have its own scope. So that's why, so if you had a top-down program that was 800 lines long, like, well, one, that's terrifying. It's just a big, long script. But that's why when we get into functions, we can be a little bit more reuse. We have some more reuse with our functions. So that if I was to call, func1 and func2 here in my program, I started up a video game. Sorry, guys. I accidentally clicked on my cool wrapper, so I'm going to have to wait for that to start up so I can Oh, good. I didn't have to open it and embarrass myself. So you can see that my var is x here and y here. So that's what. So like if you start to get to the point where like, oh crap, I'm out of good ideas for variable names, you can use function scope to your advantage there. But you also have this thing where you can have like my var is equal to lol. Oh no. Oh no. It wouldn't matter, exactly. There's no, what these two prints down here are still x and y. And now here's what I was talking about, is if you wanted to use the myvar lol in this scope, well, what happens when you do this though? Oh, okay. Well, no, we're not going to do that. Well, that would be what we should do. But in this case, we have myvar in global scope. I'm referring to myvar here in function scope. Let's see what happens. So
It's not defined in both levels.
yeah, so I have lol and y. Myvar is not empty; it's gone for the global. Now you want to see something really screwed up? This is why like I tell you that globals can really break your stuff. Let's say that I want to set the global myvar from this function. Remember when I did myvar is equal to Joel, or myvar is equal to x? So the first one in func1 sets it to x and it prints it, but it doesn't change the global. That's actually really good. But say you're a new programmer and you're still learning what's good and what's bad. You say, I believe this is how you do it. This is something that like I never do because it's a terrible idea, so I forget how to do it. I think this is how you do it. No, it's global myvar, and then you say myvar like that. So what I would expect here is that both myvars on func1 and func2 are going to print out x. Neither of them will be LOL. This is a terrible idea to do this, by the way. You will break so many things.
If you were to print my variable, it would just print the global one outside of the functions.
Okay, great example, or great question. So if I was to print myvar above where I call the function here, what do you think that's going to be? LOL, correct, because it was before I called the function. But if I was to print myvar here, it would be LOL XX and an X, because this first func1 modified the global. I'm going to say it again. I don't want to see anybody do this in their programs. This might seem, oh, cool, we can change stuff. We have so much superpowers. But like, this is like somebody grabbing a Harry Potter wand and just like doing Superman type stuff, and they have no idea how to do with it. Like,
so if you actually want, so best practice of a function changing a global variable would be to pass the function a variable, pass it the global variable, and have a return.
Yes. So again, we're jumping ahead a little bit here. Is that let's say that func1, we're going to rename that to change global, because we want to make it abundantly clear what's going on in func1. And I'm going to pass change global to be myvar. I'm going to pass myvar in there. I'm going to say myvar. I'm going to get rid of the global. Like, we're jumping way ahead here, folks. So when I print this out, I would expect the first print to be lol. I would pass myvar into change global. It would change it to x. It would print x. Then we would get x, and then we would get x. Oh, that didn't work. It didn't change the reference.
Would you have to do myvar equals change global myvar, and then have change global return?
That would be the best way to do it. Again, if we're going with best practices, I would just say return myvar, and then you would just say myvar. That's not really changing the global though. Like that is it, the best thing you could do there, because it's not actually changing it. Well, it is changing it. Technically, the best thing you could do here is just to say x. Reset myvar outside.
So I would print LOL X, X, X.
Yeah, if we put one more print here. We are way off topic, by the way.
You wrote print.
Print. LOL, X, and X, and X. Yes. So this, so scope will get you into a lot of trouble. Loop scope, it's pretty simple, or it's pretty straightforward. It won't bite you in the foot. But when you start getting into functions and global scopes, we don't deal with that. Like, that's just not something that we work with. Like, if you want to do something like this, you do it the functional way. If you want to change a global, you don't access it inside of a function without passing it in. In fact, here we don't even need to pass it in anymore. I just have a method that returns X, and then we're resetting the global scope inside of its global scope, because you don't want to change something's scope somewhere else. Like, that's where you get side effects and problems that happen. It's hard to debug that stuff, because what you'll do is you're going to look through, you're going to be tracing through all these function calls and be like, what the heck, the value of it here is X, the value of it here is X, and then randomly it becomes LOL, Y, and you can't trace that. Well, there's this random function over here that changes the global that you weren't able to easily find. Whereas if you do this, you trace through, you say, print my var, I'm going to set the value of my var, then I'm going to print my var, we're going to see, LOL, X, and X, and X. Like, that's very clear what's happening here. So, anyways, that was a little bit of a sidebar. I can't remember what time I started on it, but 11:23, Joel gets back on track with talking about loops. Tangents are fun, but yeah. I mean, I feel like we have the resources to be able to do this. So I'm gonna get rid of this as well. So just going back to the different types of ways that we can loop through here. All right, and I'm not going to introduce any different types of data types. We're not going to talk about dictionaries yet, but know that we can execute this block of code, and this doesn't have to just be one line. Like, we could put a comment in here, print more items. I could put some math. I could print like 6 plus 8. So blocks can be as many lines of code as you want. You can also make more blocks. So say, for example, we have item. So item, we all know, is going to be either the value of cat, dog, or horse, right? But we also know that we can loop over a string as well. Remember how to do that? The second example here. So this is going to be kind of crazy. I'm going to delete this. I can also for character in item and print character. So this is going to be a nested loop. So you can put loops inside of loops. It's like Inception. It gets, every time you go down, it does a little bit more work. So when we print this out, we're going to see dog, D-O-G, cat, C-A-T, horse, H-O-R-S-E. This is a great way of, like, if you have rows and columns. It's like you could imagine that dog is a row, and each individual letter is a column. So when you have dog is a row of items, you can go through each one. First column is D, second column is O, third column is G. And that's how that happens, is that this nested for loop is going to go in detail and print out each individual character. We're not going to be doing that tonight's assignment, so don't worry about that. I'll leave that there, though. So, loops, run 5 laps around the building. You're done when you're done. Like, that's why you would want to use a for loop. Now, a while loop, that's going to be a condition. So, like I said, that condition could be anything. It could be like until the time is equal to 11:25 or 11:26. It could be when a random number is equal to 20, kind of thing. So let's cover a couple of things here. Let's kill 2 birds with 1 stone, because we also have to cover randomness. So let's make a loop that is going to run until it guesses a random number of. Wait, no, that's part of your homework, isn't it? Like, I really wanted to do that, but I'm like, that sounds like a really cool idea. Well, how about we do this? How about we talk about this method, but you're not allowed to implement the brute force while loop method. Okay. You have to implement the high-low method. So that just takes the hard mode out of it. Just turns it right from easy mode or normal mode to ultra hard mode. I like that. I like that. No, I don't like that. I'm going to quickly think up off the top of my head how we could display because I don't want to do a while loop that just re-implements a counter. That's boring. I'm going to do a while loop.
Could you do something where?
Why is there smoke rising? What happened?
It's this guy here.
Oh.
Sorry.
I thought our building was about to
Computer's
burn
working
down.
hard.
my nicotine habit.
Okay. That's
So what about
Smoking cigarettes.
pass it a number and then have it guess random numbers and count how many iterations it has to go through before it found the number that you input?
yeah. So that's the hard mode of tonight's assignment.
Oh.
Well, you know what? No, I'll change the assignment. That's fine. I really like that example because we have to cover randomness. We have to cover while loops, and hard mode is optional, I guess. So I can just remove hard mode and move the harder mode and put it in there. So the while loop, what I want to do is I want it to be able to calculate a random number, and I'm going to like preset a number. So like my number is equal to 30. That's the number that I pick is my random is my number. You can pick whatever number you want to. Just make it between 1 and 100. And what I want to do is I want to make a little while loop that will continually guess a random number. And if it doesn't get the correct random number, it takes another guess. And it will guess again until it actually finds it. This is sort of the whole, if you put enough monkeys into a room, the infinite monkeys problem that will generate Shakespeare. So if we leave our computer alone long enough to generate random numbers, it will crack and figure out our number of 30 and gain access. So I guess technically this is kind of a brute force password hacker too. So this is kind of a rudimentary way of showing how that thought process works. So what I want to do is I want to generate a random number. So in order to do that, we need to import a module from the Python standard library. Now this is not being pulled in from the internet. This is built into Python. We want to import random. And we want it to generate a random number. We're going to say computer number is equal to. So we're going to save that to a variable called computer number, and that's going to be random. That's the module, and we're going to call a method on that module called randint. Not random. It's randint because we're guessing integers. If we did not guess an integer, if it was going to guess like a floating point number, we'd be here forever. We're going to generate a random int, and we're going to tell it between 0 and 100. And before we get into the loop, let's just print out what the computer number is. Like before I actually test that this is guessing anything, I want to make sure that it's random between runs. So I'm going to run it. Okay, the first time it's 85. Second time it's 73. And you continue to run it. It's 36, 20. That looks random to me. Pseudo-random, technically, but it works the way I would hope it would. So what is the condition that we described? Like, think of it in computer terms. What is the condition that I want to iterate through? Like, I want to keep iterating as long as this condition is met. Think like a computer would think.
Computer number equals 1.
My number not equal.
Right, there you go. So you think of how the computer wants to do the work. So as long as the condition that my number is not equal to the computer number, we want to do work. So I'm going to say while, this is the syntax here, we say while my number, this is kind of the Yoda way of saying it. I think the more straightforward way of saying it is while computer number is not equal to my number, what do we want to do inside of the while loop?
Continue generating new numbers.
We want to call that line again. So I just copied and pasted this line here and put it into there. So this is a great way of dealing with indeterminate amounts of loops. It's like, how many times is that loop going to run? I don't know. Is it going to run 100 times? I don't know. Possibly. Is it going to run 1,000 times? If my computer gets really bad RNG, probably. So what we're going to do is we're going to run this. And we're going to see that sometimes it might be slow, sometimes it might be fast. That was fast. That was really fast. That felt a little bit slower. We really have no analytics, do we? So let's put some analytics in there because the program is obviously done running. So that means that it eventually guessed it. So one of the things that John said was, how many times does it take the computer to guess it? So before we do this, and you saw how fast the computer was running, how many guesses do you think it's on average taking the computer to guess just using this brute force method? 1, 50, 100, 50 on average?
Sure.
Let's find out. Let's get that question answered. Our hypothesis could be 50. We have a confidence of 50. So what we're going to do is we're going to create a counter variable called 0. Actually, no, what? You know what? Let's say counter of 1 because we already guessed one random number here. We're putting it below our computer number outside of the loop. So yes, you do need to define counter outside of the loop. And I want to, after it generates that random number, I want to increment the counter by one value, by one number. So the longhand way of doing that is going to be counter plus, or counter is equal to counter plus 1. So that no matter what the value of counter is, it's going to just add a 1 to it, and it's going to reset counter to it every loop that it goes through. There is a shorthand way of writing that, but we're not going to worry with that right now. That's a little bit better way of understanding what's going on. And that's all we have to put in the while loop. And then at the very end, outside of the while loop, print the counter. So that's going to tell us how many guesses the computer made. That's going to give us this answer. 29, 41. So sometimes it's lucky, sometimes it's not.
From 16 to 119.
Wow. Yeah, 165, a new high. But we can actually, we can make this computer, we can make it kind of burn, right? Like, I can have this computer generate random numbers between 0 and 100,000. And we can see how long this computer takes to brute force through that.
Yeah.
Didn't take very long. Didn't take very long, though. 36,000 attempts. This is why brute force password breaking is terrifying, just on a consumer-grade computer. Now think, you've got 5 supercomputers running in the cloud, all attacking this password hash. It starts to get really scary, even when you're like, oh yeah, those passwords are encrypted. Well, and they pass out metrics like, oh yeah, that would take a computer 5 years to crack that password, or it would take it 1,000 years, or 10,000 years. It's like, okay, it would take one computer 10,000 years. How long would it take 10,000 computers? How many phones are there in Greenville?
Yeah.
How many computers are there in the world that could be hijacked to do this work? So anyways, I'm getting tinfoil hatty here. So,
Quick question.
Yes.
The random integer, is that inclusive of the last number?
No, it is not. So that means that the guess is going to technically between 0 and 999999999. So this number here is 10 million. Let's see how long it takes to crack 10 million between 0 and 10 million. 999, whatever. Let's go do some work. We're probably going to hear the fan turn on here. All right, it took 2 million guesses, 2.6 million guesses. Now here's the thing, that this is where encryption tends to really start to take off, is that your password is not a number. And it's not like a number that could have randomly chosen bits or something like that. It's not like A, B, C, 1, 2, 3. So right now it's just each bit has the possibility of being 1 or a 1, 0 through 9 basically. When you start making alphanumeric, A through Z, which is 26, and then 0 through 9, and then when you add special characters in there, the possibilities become much higher. So if you want to get to a statistical standpoint of it, this is only guessing potential characters between 0 and 9 in each of these bits and places. So it will guess it in a couple of seconds. But when you start getting into 64-bit hashes that have special characters, all sorts of crazy things, that's when the entropy and the amount of time that it takes to brute force through it is much higher. Like that's when you get into, it'll take one computer 10,000 years to break through it because of the amount of time it takes to run through one iteration. So that was a fun sidebar. So yeah, it guessed. Now I'm not going to allow anybody to submit this for hard mode. For the hard mode of tonight's assignment, you are going to be doing the high-low method. You're going to be implementing that for the computer to decide, which it's not too huge of a jump because you're going to implement it for yourself. And that your hard mode can be its own file too. You don't need to put them in like homework.py and homework.py or homework. You have to put them both in your homework.py. You can put like homework and then homework_hard.py if you want to try it. That way you don't screw up your regular mode. Yeah, if that's what I suggest. That's why I highly suggest you work that way. So how are we feeling about for loops and while loops? I feel like we've done a pretty good job illustrating that.
Only other question is I've seen some places with loops where it has the bracket and everything within the brackets is run through that. With this, there's no brackets, so it's just everything that's indented within that is included in the loop.
So that is a feature of Python. So the question was that in programming languages like in C# or JavaScript, there are brackets that denote the beginning and the end of the block. In Python, the colon at the end of a statement like this and an indentation denotes the block. So when you use and there's a phrase in Python programming that says white space matters. Like white space does count because in a lot of programming languages, like in JavaScript, it's just like it can go all over the place. Doesn't matter. Like you can put 5 spaces here, 10 tabs down here. There's even a fun thing. There's a contest, obfuscated C contest. These are a lot of fun. What people do is they do ASCII art with programs. So let's see, where is it? Judges. And these are things that you can do right. Oh, here we are, winning entries. 2018 already. So that is an actual program that runs and does something. And it looks kind of, what is that, like Taj Mahal or something? No, Hagia Sophia spectral leakage. Anderson made, it looks pretty neat. But these are like, oh, it's downloading that one. That's not terrifying to me at all. How about I not download a random C program from the internet? Probably my favorite, type of code contest like this. It was a while ago. It was probably in like the early 2000s. There was a contest it was called a Quine. Is that you have to write a program that outputs its own source code. And somebody won by submitting a blank file.
Brilliant.
And then they made the rule because of that said that you have to have a minimum file size of 1 character. So kind of screwed that up, but yeah, these are a lot of fun. Oh, it actually says something. It says calc. But with Python, you can't do that. Because Python, you have to work with the white space to denote your blocks. You can, I have written some pretty obfuscated Python in my day. You can use semicolons to put things on one line, but you can't do that with like for loops as far as I'm concerned. Like, so for example, if you have multiple prints, you can put like print counter, print awesome. Like that's valid Python. Not very good Python. You will get your wrist slapped by me if you do that, but it is valid. Cool. So any questions about any more questions about for or while loops? We will be seeing a lot more of the indentations over the course of our careers, especially with Python, because it does matter. Like that was John, if I can reveal, like John pasted his homework in, it didn't retain the code formatting. He had some indentations in there, and as I was like looking at it to make sure it was doing what it was doing, I didn't have any of the indentation information, so like I did my best to say, like, okay, what was he intending to do with the indentions? And I couldn't make sense of it, so he had to resubmit it. So. Cool. All right. So Randomness, yeah, and that's really all you need for tonight to guess to give you a random number. We're not going to go in depth on random distributions. This is not a data science class. So random.randint is going to be really the big part of what we need to do. Next week we will get into random.random. That generates a random number between 0 and 1. We use those for you can use that for a percentage modifier, because if it's going to be like 0.89, that equates to 89% of something. So when we get into like a bike race and we want to apply a random slow modifier to somebody to see how much they should slow down randomly, that will calculate a random slow modifier. Oh man, they hit like 0.21. So we're going to multiply their current speed by 0.21. So random.random will give you like something between 0 and 1, including 0. So if somebody hits the random modifier of 0, they will just stop. And then they won't be able to start again because they're constantly being multiplied by 0.
How would you break out of a while loop? Like if you have an if inside of a while, and then if the if is true and you put break in there, does that break from the if or does that break from the while?
Great question. So the question was, how can you exit early out of a while loop? I probably should have covered that. I'm doing a bad job today. Because, yeah, this is taking a really long time to run. And let's say we want like another exit condition. Say if it's an odd number, maybe we want to exit out early. Or maybe if it's a prime number, we want to exit out early. Well, I'm not going to put a prime solver in here. But we can I'll just control C out of the program. But I can show you how we can exit if it's an odd number or if it's an even number. Either way, we can say that. So the way that you would check to see if it's an odd number or an even number, and don't pay any attention to this part, I'm going to put an if condition in here, which we're going to get into in just a second, but I think we'll be all right from the pre-work. So I'm going to say if the computer number is mod 1, that's an odd number. So usually in a function you would return out of there. But in a while loop, you would break.
And that would break out.
That will stop you out of the while. There are two ways to break. There's one way to break out of the loop. That's by using break. But you can also use a continue. So for example, let's look at this right here. We're writing a lot of code, and something's going on here, and I could give this to you as a junior level developer who is wanting to apply for my company and say, this could be made better. Let's talk about it. I'm not asking for you to fix it for me, but let's have a conversation about why this could be made better. Now, I guarantee you're never going to get that good of an interview question. Like, that is a softball served up on a plate. Typically, you're going to get something like, fix it. Somebody's just going to poke your computer screen and say, fix it. But in this sort of master's level studio that we're going to have it's like, let's have a discussion about what can be done to make this better. So anybody have any ideas just off the top of your head why this could be made better? And this is like next level thinking here, like a 200 IQ play here. It has to do with when we're breaking. And when I say optimize, I don't mean we're not optimizing by like a million seconds. This optimization is like an atomic calculation, pretty much. It's like it's going to save us a nanosecond, but it's an optimization nonetheless. So if I had, let's think of this with like an analogy, okay? If Zach's going to make us lunch, okay? Zach's going to make everybody a sandwich, and he's going to go through, and he's going to make sandwiches for a very long time, but the minute he encounters like a food allergy, he stops, okay? So what he does is he makes a sandwich, and first up is Kevin. He says, "What do you want?" And he says, "Okay, I want peanut butter and jelly." Everybody's thinking about their lunch now, by the way. And so Zach goes and makes peanut butter and jelly, and says, do you have a fish allergy or whatever the allergy was? I forgot. Fish allergy? It's like, no. It's like, all right, here you go. Cool. And goes to John and says, what do you want for lunch? I'm going through this loop right now, by the way, really slowly. This is exactly what this does. It says, John, what do you want for lunch? He says, I want nachos. I want Doritos on my sandwich. He's like, okay. So he crumbles up some Doritos, puts some ranch dressing, some pepperoni on there. I said, yeah, I've been hungry before. I know a thing or two about stylish junk food. And says, here's your nacho sandwich. By the way, do you have a fish allergy? He says, yes. And he's like, okay, I'm going home. And he leaves. What seemed really, like John never got a sandwich.
There's no fish on the sandwich.
There's no fish on the sandwich. But you left early because you had this rule, this random-ass rule that some programmer told you that might make sense. So how could we optimize that process? Because you still need to leave at the fish allergy. But you still made a sandwich and you never gave it to him. So what should you have done better in that process? How could we optimize that process so that you don't have to make this stupid sandwich and you could just leave, right, when you find out that there's a fish allergy? You don't want to have to make a sandwich.
Yeah, ask before we make the sandwich.
We want to ask before we make the sandwich, like as any chef should ask about food allergies so that they can do some other stuff. Because what's happening here is that we're coming in here and we're saying, hey, we want to make a new random number, or our numbers aren't the same, so let's make a new random number. By the way, if the number is odd, stop. So we can take this and we can move this to the top of the while. Whoops. That way, at the beginning of every calculation, if it's odd, we just walk away. We don't worry about making that nacho sandwich. But if it's not odd, then we could say, okay, you don't have a fish allergy. I'm going to make you your peanut butter and jelly sandwich. So when we run this now, I started it again. I really need to move this like way down here, like not in the trash.
Not that low.
There we go. I can't play that game right now. I know you want me to play, but it calls to me. So when I run this program now, watch what happens to our amount of iterations that it counts through. Uh-oh. What did I do wrong?
Still running through a lot.
What did I do wrong? We have to debug this. I'm half serious. What did I do wrong? And how can we figure out how I did wrong? Let's do some debugging here. Like if this is your program tonight, what's your step? What's your play? What is your gut reaction to figure out? I expected that to only run like twice and then get out of there. Not like 300 million times. So what kind of information do you want earlier so we're not sitting there wasting 5 seconds of letting it run? What kind of information would be best to find out?
Oh, if my number is odd.
If my number is odd? Okay. Well,
Well, no, because then it wouldn't even.
the computer number should be odd too. Like it doesn't matter if our number is odd. If they're not the same, but the computer number is odd, we still want to break out. What I want to say is, why isn't this breaking? So, let's take a closer look on line 27 here. Computer number, so if computer number mod 1. Well, first off, let's just find out what the heck happens when you say 7 mod 1.
So it's not showing it's true or false. It's showing the actual.
Now, the thing is that it's always 0, even if it's an odd or an even number. You see that? That's a bug. So what happens when you divide a number by 1, by the way? Boom! So we haven't covered what the modulus operator does yet, but the modulus operator is going to divide it by 1, and then it's going to return the remainder. So if you have 7 divided by 1, what is your number? 7. 7 divided into 1 piece is still 7. So what if we change that to be 2? 10 divided by 2 is what number? 5 with no remainder. What about 9? Like, does anybody else panic when someone asks you to divide an odd number? I do. I'm ruining the day that my son comes home from school and he's like, hey, we need to do division of odd numbers. I'm just going to be like, oh, I need to go take a nap.
It's that time.
Because what I can tell you, though, is that there's going to be a remainder. Like, that's going to be an actual, like, floating number that it's going to return. If we did 9 divided by 2, it's going to be 4.5. So I don't know why I panicked at that. But that means that our code is broken. It's not mod 1, it's mod 2. So you see how to debug that, I didn't sit here and continually run and all this stuff. I just want to say, like, what is happening here? What does this code do? Does it do what I think it does? Because this was just me being kind of a gunslinger and trying to remember, like, oh, does it mod 1 or mod 2? Realizing it was wrong, and that mod 2, so that if it is mod 2, that means that it returns a 1. It means that there is a remainder, meaning that it's an odd number. If it is mod 2 and it's 0, that means that there is no remainder, and that doesn't drop into the if block. Because remember, well, we haven't talked about it yet. I would say remember. But in an if block, it has to be true for it to fall into the block.
So do you not have to have a qualifier there? So
Oh, yeah, so
mod 2
is double equals.
1.
So in Python, you don't. It's actually really nice because if will check what's called truthiness of it. Now, the real easy one is I could say, hey, is true truthy? You'd say, yeah, true is truthy. And I'd say, is false truthy? You'd say, yeah. No, it's not. No, false is not truthy. Doesn't make any sense. But then I'd say, is the number 1 truthy? Now, this is where Python implements its own rules. Like, yes, 1 is truthy. So if 1 is truthy, what is 0? Not truthy. What is 2? Truthy. 3 is truthy. So basically, so you have different types have truthy values to it. So like a 1 is truthy, but a 0 is falsy. It's stupid because they don't say false or true. They say truthy or falsy, meaning that it is a false-like. So when you have like an empty list would be falsy. A list with 1 or more items in it is truthy. A -1. What do you think a -1 is? Truthy, absolutely. So when you don't give a qualifier here, it checks the truthiness of it. So if you just say if computer number mod 2, that's going to be a 0. It's going to say is 0 truthy or falsy. And if it's truthy, it's going to fall into the break, meaning that if it's an odd number, it will fall into there. Because 1 is truthy. 0 is not. So this is the code to say if a number is odd, run this code here. It's a little confusing. It's not incredibly clear. But I could, if I wanted my code to be more clear, I could say is double equal to 1. That is a very specific way of saying don't check the truthiness value. That computer number remainder needs to be double equal to 1, and we'll break into here. That is a much clearer way to do it, a way I probably should have done it, to be honest. So when I run this now, notice that it only took 3 guesses. That's actually really inefficient. It took 3 guesses to finally hit an odd number. 2 guesses. There we go. 1 guess. 1 guess. 7 guesses! Those dice were hot. Okay. Let's spend 10 minutes talking about conditionals. We already started talking about truthiness and whatnot. And that way you'll have all of the you'll have all of the pieces necessary for tonight's normal mode homework. It is gonna be okay. Yeah, there's gonna be some fun stuff. I expect to get questions this afternoon, so make sure you're asking me questions this afternoon. Okay, let's create a new file before we leave here for lunch. Make a new file. This is going to be called day_2 conditionals. And this does kind of jump ahead. What I had was like this is going to be Thursday stuff, but there's no reason to wait till Thursday. Okay, conditionals in Python it's not too broad of a topic, but they're going to be used everywhere. They're used in every programming language I've ever used. In fact, it's a way of having branching logic in your program. And so what I mean by that is your computer or your program needs to act in a certain way given a certain set of conditions. That certain set of conditions is in the case before was that this number was odd. If this number is odd, break out. We could have even given it an alternative condition. If it's even and it's divisible by 6, do something else, like print, we found it. And so this is kind of what I was talking about the other day with the FizzBuzz, with the foobar thing. That we can code that up really quickly, piece by piece, if we wanted to. And it will use the modulus operator. Remember I said if it's divisible by 3, or if it's divisible by 5, we could do that with just an if and an else and a print statement, which is why I say it's really goofy that it's even a coding problem at all. But let's look at some things. So what I want to do with my first input is I want to do like a string comparison. I want to input my name, and if it says Joel, I want to say welcome Joel. If it's not Joel, it does get the heck off my computer, because we want to write like a little tree here. So let's say my underscore name. We're gonna make a variable called my underscore name, and that's going to be an input that says what's your name. I'm going to write an if here that says if my name is double equal to Joel, I want to print welcome Joel. Now we can test this out. We can write Python day 2 conditionals. Let's say, what's my name? If I type Joel, it'll say welcome Joel. If I say Aaron, it won't say anything, because we don't have another condition for that. Now, what if I wanted it to say, if I typed in any other name? I'm not asking the question, by the way, so don't think that you need to shout it out. So it's so my next play is I want it to say everybody else that's not Joel gets a go away message. So the condition for that is called else. Else will say if anything other than my name is equal to Joel will fall into this little block. Say go away. And in an if and else block sort of conditional statement, only one of these will ever be called. There's no way to go from an if to jump down to an else. It's like saying if, you can't fall into two conditions at once. I'm trying to think of the best way to describe that, but I think we're all kind of grasping at that. We're all grasping it. I hope, at least. It's like when you eat your dinner, you get your dessert, right? It's like if my dinner is gone, you get your dessert. If you didn't eat your dinner, you don't get your dessert. So they're like equal states. Like you can't be in a state where you don't get your dessert and your dessert at the same time. That's kind of how you want to treat your blocks. So if I run this and I say my name is Joel, it's going to say welcome Joel. If I run this and I say my name is Aaron, now it says go away. So that is the basics of an if-else. But there's also this thing called, is it else? Oh gosh, else if? Oh no, my Python is so rusty. I think it's else if. I've been writing so much Perl. Else if Python. That's the problem, is that I always get else if.
It's
Elif, thank you. Thank you. That's embarrassing. Because in Perl, it's else if. Elif is in Python. Thank you. So in elif, you need to provide a statement. You need to say if my name is Joel or if my name is double equal to Sarah. Sarah's my wife, so I'm going to say, Neato, you're back, Sarah. So this is allowing me to create branching conditions of something that can happen. I run this. I say, Sarah, neat, you're back, Sarah. Joel, welcome back, Joel. I run it. I just give a gibberish name. It says go away. All right, now we want to do a conditional. The interesting thing about a conditional is that this expression has to be a Boolean. It has to evaluate to true or false. Now, it could also be truthy or falsy. So if I just said if 0, here's a quick little quiz here. If 0, print, it's 0, you dingus. That would never run. That code right there would never get ran. Like, even if my computer decided that now binary is no longer binary, everything is quantum and it's craziness, that code would still never run because 0 is falsy. This code will never run. It will never say 0. So that's a weird condition. So what I want to do is I'm going to do some math now. Like, let's ask the user their age. Let's say my age is equal to input. What's your age? And let's say we only want to allow people on this computer who are older than 18 years, who are 18 or older. This is like an adult computer, right? Maybe there's some bad language or something on it. So what I would do there is I would put a Boolean expression like we talked about yesterday, where you can say if like a number is larger than another number. We could say if my age is greater than 18, I want to print welcome to the adult computer. And then I would put an else here to say go away. So if your name is not Joel or Sarah, it tells you to go away. If you're not over 18, it tells you to go away. Now I added a bug here because I want to talk about some form of the greater than, less than, or equal to operators, because this will only work if the number is greater than 18. It does not include the number 18 because it's not a greater than or equal to. It's always going to be greater, literally greater than. So if we run this and I say, my name is Joel, it's going to say, welcome, Joel. If I say, what's your age? I say 35. Oh, whoops. What happened here?
The number as a string. You said inputs default to strings, right?
Inputs always default to strings. So, this is something that you're going to have to code around tonight for your program, because you're going to have to input a number, right? And that number is going to have to be bigger or smaller than something. Convert a string to an int. I'm not giving that one to you. That one is on you. I will answer questions if you show me a good if you show me a good attempt. I can tell you if you're close or if you're way off. Or you just need to Google, how do I convert a string to an int? Google will tell you. See, those are the kinds of things. Okay, I'm going to turn the camera off, or the camera. I'm going to turn the recording off because I'm going to get real here.
You almost clicked on that game.
I want to play.